Now let's show how to do the inductive step for the same problem. What we need to do is show that for every k that's an integer that's greater than 2, and the reason it's 2 is because we have 1, 2 as the second subscript, the last case of the basis cases, we need to show that if this property, that it's divisible by 4, is true for all of the ones up through k, that implies that it's true for the next one, k plus 1. So we're going to assume that k is greater than 2 and that it's an integer. We're going to assume that 4 divides b sub k for all of, that should be b sub I. It's easy to mix those up. Make sure you don't do it. We're going to assume that 4 divides b sub I for all of these subscripts, I, from 1 up through k. We want to show that 4 divides the next one, b sub k plus 1. Now, if we use our formula, which you'll see in the next section is really a recursive formula, b sub k plus 1 is equal to, put in the k plus 1 where you see k in the formula. Okay, there's the original formula. It's going to be k minus 2 as a subscript here, k minus 1 as a subscript here. So we're going to take k plus 1 and subtract 2. Here we're going to take k plus 1 and subtract 1. So b sub k plus 1 is equal to b sub k minus 1 and b sub k. Do notice both of these things are inside of this range, which means 4 divides b sub k minus 1 and 4 divides b sub k by our assumption. Our assumption being the inductive hypothesis. Now, what does it mean that 4 divides this? Well, the fact that 4 divides this, what? Means there exists something that's an integer where b sub k minus 1 is equal to 4 times that something. And here, well, we have to pick a different letter that's an integer, and we know b sub k here is equal to 4 times that integer. That's done by the definition of divides that we did before. So we know this happens because of our inductive hypothesis, and this is true because of the definition of divides. Alright, now to finish this, what I'd like to remind you is that we got to this expression here by looking at our formula, our recursive formula, that b sub k plus 1 is equal to these two things added together. But b sub k minus 1 we saw as 4 times some integer, and b sub k is 4 times another integer. Well, the algebra here isn't too tough. We can just take the 4 out of both terms, and if we let, z equal to that sum, the sum of two integers is an integer, so we see this is 4, we see this is 4 times some integer, so that means b sub k plus 1 is divisible by 4. I guess I should write it this way. 4 divides b sub k plus 1. I think that might be the easiest way instead of writing the word divides out. Then we have proven the inductive step. So by the principle of strong induction, We know that 4 divides every one of these b sub n's for all of the n's greater than 1. And we are finished.